For this first linear programming question, K-Star Company can use plastic, aluminum, or a combination of both to make its products. They cannot use more than 20 units of plastic. They must use 30 units of aluminum and must have a maximum cost of $504. If each unit of plastic weighs 5 pounds and costs $6, aluminum weighs 30 pounds and costs $12, how many units of each should be used to maximize the weight? Well, in these linear programming questions, there's always going to be two values, two items. And here it's clear that the two items are going to be the plastic and the aluminum. And the question says how many units of each should be used to maximize the weight. So we're always going to start off with let statements. I'm going to let X be equal to the number of units of plastic, and I'm going to let Y be equal to the number of units of aluminum. And I'll stay consistent with those variables. Now for the objective function, what you always do is you always look for the words maximum or minimum. Usually in the problem, they'll indicate whether you're trying to maximize or minimize, because that's what the process of linear programming is all about, maximizing or minimizing. And here it says you want to maximize the weight. So I'm going to first try to write an objective function which talks about the weight. And I'm going to get that information right here. Plastic weighs 5 pounds. So I'm going to take 5 and multiply it by X, the number of units of plastic. And then I'm going to add to that, it says aluminum weighs 30 pounds. So I'm going to add to that 30 times Y, the number of units of aluminum. So the equation, the function that I want to try to maximize is 5x plus 30y. So the way you get your objective function is you always look for the words maximum or minimum. Now we need to write a series of constraints, inequalities, that represent what's going on in the story. And we'll kind of go sentence by sentence. The first sentence kind of gives you the let statements. It says they cannot use more than 20 units of plastic. So since X is the number of units of plastic and they cannot use more than 20, that means they have to stay less than or equal to 20. So that's our first constraint that we're going to write. X is less than or equal to 20. Next it says they must use at least 30 units of aluminum. Well, Y is the number of units of aluminum. At least in math means greater than or equal to. So Y must be greater than or equal to 30. So that's my second constraint that I need to write. You must have a maximum cost of $504. So that means the cost has to stay less than or equal to $504. Well, here they mention some costs. Plastic costs $6. So I'm going to take 6 and multiply it by X, the number of units of plastic. And aluminum costs $12. So I'm going to take 12 and multiply it by Y, the number of units of aluminum. And that has to be less than or equal to 504. Well, it looks like I've used all of the information that's given in the problem. Now I want to check to see if I have minimum value inequalities. I want to look at each of the variables and see if I have an inequality that represents its lowest possible value. And X stands for the number of units of plastic. And this first inequality, X is less than or equal to 20, that's not a minimum, that's a maximum. It's telling you the number of units of plastic can't go over 20. So that's not going to be considered a minimum value inequality. So what I'm going to need to do is I'm going to need to add in X is greater than or equal to 0, because that tells me the minimum value, the lowest possible value of X is 0. They can make 0 units of plastic, but the number of units of plastic can't be negative. Now look at the Y. Here you have Y is bigger than or equal to 30. Well, basically what that's saying is the number of units of aluminum can't go lower than 30. So that's actually a minimum value for Y. So the only other inequality I needed to add was X is greater than or equal to 0, because Y is greater than or equal to 30 is the minimum value for that variable. So this problem here is going to have you graphing these 4 constraints, and we want to try to find the solution area, and then more importantly, we want to find the vertices, the corners of the solution area. And a lot of times, getting the viewing window set up properly is the challenge. But we're going to use these constraints to help us set up our viewing window. For example, I know that X is bigger than or equal to 0. So that's the minimum value for X. So I could make my X min 0. What I'm going to do instead is I'm going to go and make my X min negative 5. Because what that's going to do is that that's going to push the graph up so that it's more readable when we get our solution area. But you could have, especially on the newer versions of the TI-84 graphing calculator, you can have an X min of 0, but you'll see why I'm making mine negative 5. Here I know X has to stay less than or equal to 20. So really the biggest X value I have is 20. So that's why what I'm going to do is I'm going to make my X max 25 to go a little bit bigger than the biggest X value that I have. Here I have Y is greater than or equal to 30. That's my minimum Y value. So maybe what I'll do is I'll make my Y min 25 or even 20. Go a little bit lower than your minimum value. And what your Y max is going to be, well, right now, I don't know what my Y max is going to be. So what I'm going to do is I'm going to kind of set it at 50 and hope that's going to be good enough. So that's the viewing window that I'm going to use. And now what I want you to do is take a few minutes, come up with the solution area, and put the picture in this viewing window. Remember, this in equals app is very methodical. You're going to have to first graph it and then tell your calculator to go to the inequality intersection. So here is what your solution area should look like using the viewing window that I described earlier. And what you have to do is you have to go about finding the vertices. You have to go about finding the corners of the solution area. And it appears that there are going to be 4 vertices of this solution area. Now, using the point of interest, or the POI version of the calculator, you want to go about finding the vertices, the corners of that solution area, because those are going to be your potential X and Y values for your answers. So here are the 4 vertices of the solution area: 0, 42, 20, 32, 0, 30, and 20, 30. These are going to be the potential X and Y values that you're going to plug back into the objective function, and try to answer the question. In this case, the question said, how many units of each material must be used to maximize the weight? So here we're going to go the maximum weight, 5x plus 30y. So we'll go 5 times 0 plus 30 times 42 for this first vertex. Then we'll go 5 times 20 plus 30 times 32 for the second. 5 times 0 plus 30 times 30 for the third. And then 5 times 20 plus 30 times 30 for the fourth. So you basically plug those right into your calculator, and you see which one gives you the maximum value, because you need to find the maximum weight of this material. So it looks like here, the maximum weight of 1260 occurs at this vertex, 0, 42, meaning you should use 0 units of plastic, because that was our X value, and 42 units of aluminum. So that's what linear programming is all about, maximizing or minimizing particular values.